Think math.
A single one at the top. The two edges are always 1, and each inside number is the sum of the two just above it. 1 plus 1 is 2. Keep stacking, and you get Pascal's triangle. And hidden inside this simple triangle are all the coefficients of a plus b, raised to any power. The rule is all there is. Add the two numbers above and write the total between them below. 1, 1, below that, 1, 2, 1. Next, 1, 3, 3, 1. Then 1, 4, 6, 4, 1. With nothing but addition, the triangle grows forever. Now, the magic. A plus b on its own has coefficients 1, 1. Square it, and you get a squared plus 2, ab plus b squared. Coefficients 1, 2, 1, exactly that row of the triangle. Cube it, 1, 3, 3, 1. Whatever the power, its coefficients sit right there in the triangle. Why? Because a plus b cubed is a plus b squared times a plus b once more. Multiplying the old coefficients, 1, 2, 1 get copied once times a, and once times b shifted over by 1. The two overlapping copies add 1. 2 plus 1 is 3. 1 plus 2 is 3. 1. That overlap is exactly Pascal's rule. Add the two above. There is even more. Each number counts the paths from the top down to that spot, down left or down right at every step. So these are the combination numbers, the ways to choose some from many. And add up any row and you always get 1, 2, 4, 8, 16, the powers of 2. Add the two above. From that single rule, the binomial coefficients, the combinations, and the powers of 2 all come pouring out at once. A slice of math every day here at Think Math.